All right, good morning, class. Today we are just going to take a few minutes to finish up some areas of your notes that might be a little incomplete. So one thing that I want to do is go over and complete this pH scale at the bottom of the third page, going into your acid and base notes. So I'm just going to kind of try to draw the best I can. Here is the line at the bottom of your page, and you've got 7 right in the middle. So go ahead and label either end of the pH scale. So this would be 0, and hopefully you know by now that this would be 14. So we're going to take a few minutes just to kind of review that this side of the scale are acids. So you can write this in as I'm writing it here. Sorry for the sloppiness. And this side is bases, and right in the middle is a neutral. Okay, so with that, then we're going to talk about just some everyday acids and bases that you're in contact with. You do need to be familiar. I know that the digital video went over some, and there were some in your textbook when you did Cornell notes. And then even through the labs, you probably realized some too, but I'm going to give you general things. So basically, acids, in general, everything that we drink is an acid. So that can be coffee, tea, water, unless it's pure water, milk, pop, and juices. So all of those are acidic. Some are much more acidic, anywhere to maybe a 3 on the acidity level to anywhere from like 6.5. So some are kind of weak acids. Another example of everyday acid would be, all right, so another one would be fruits. Again, some fruits are very acidic, but others are weaker. Another interesting thing is everything that is in digestive tract. Okay, wow, that's really bad. But in our digestive tract, like if we wanted to talk about saliva in our mouth, or our stomach acids, or even urine. Okay. And last but not least, I'm going to kind of write this one off to the side, large batteries. And what I mean by large is just things that might be used for like motor vehicles, example, car batteries. Okay, those would be acidic contents in the battery. All right, so next over here for the bases, common bases are usually like baking ingredients. So what I mean by that would be like baking soda, baking powder. Okay. So when we make cakes or breads or things like that, usually those things that we're putting in, a lot of them are bases. Other bases that you can come into contact on a daily encounter would be cleaning products. Okay. And that can be cleaning products for your body, like shampoo or soap, but it can also be cleaning products for the house, like Windex and kitchen cleaner. And last but not least, we have household batteries. So those batteries that you are more in contact with, like ones for your cell phone or D or AAA or AA batteries, that would be an example of a battery that is a base. All right. Neutral, really the only thing is pure water. However, there are some things that come really close to neutral, so sometimes they're considered neutral, which one of those is blood. Okay. All right, we're going to go to now, I'm going to flip back over to the PowerPoint, and this again is in Blackboard under units of study, and we're in the matter unit currently. This just gives some more examples. Some of those we had in our labs, and some of them we just talked about or read about, but those are just some more examples. We consider a strong acid to be anywhere from 0 to 2. So the 3-4 range is just kind of like an average acid, and then the 5-6 range would be a weak. A strong base would be 12, 13, or 14. And again, the closer you get to 7.1 would be a weaker base. Also, just reviewing a little bit more about the labs that we did. Remember that when you had a substance that was indicated to be an acid, because it the indicator, either red cabbage juice or the universal indicator paper, changed color, that represented a number between 0 and 6 on the pH scale, then that tells you that if we could see with a microscope the ions floating around in that solution, you would see either H+ ions, or those H pluses bonded with a water molecule and became H3O+. For bases, the indication of a base means that there are OH negative compounds floating around. And that can be because they broke off of a base that was placed into water, or because a base broke apart a water molecule. And so the water molecule, which had been 2 H's and an O, broke into 1 H positive and 1 OH minus. So basically, if you see OH minuses floating around and there's more of a concentration of those, that means that the solution is a base. All right, moving on. Make sure that you have this chart filled out. It is the last page in your notes, and it's just describing the physical and chemical properties of acids and bases. So we'll start with acid. The first is that an acid can taste sour. That is a physical property because, again, we're using an observation of taste, and we would taste that it's sour. Now, clearly, we do eat acids because we eat fruits and we drink, and so therefore, we are consuming acids all the time. However, we want to be careful about not obviously consuming acids that could be bad for our health. Also, another physical property is that it conducts electricity well. So in the future, we might have the opportunity to construct electrical circuits using acids. Lastly, chemical property for acid is that it is corrosive. Corrosive meaning that it has the power to cause irreversible damage. And just to go a little further in detail, this up here is a diagram showing images of a nail that has been placed in stomach acid. And so you can see over a few days, it starts to break down, and that is metal. I'm guessing that they're made out of iron. So stomach fluid, stomach acid can be very, very corrosive. It is a strong acid. All right, describing a base. So 3 physical properties. One is that they would taste bitter. So again, we do sometimes eat bases, especially if we are eating breads and more like bakery items. We are eating things that have bases in them. They taste bitter at times. They feel slippery. So if you think about how soap or shampoo or laundry detergent feels when it gets on your fingers, that would describe what a base feels like. Also, we have that it conducts electricity. So not only do acids conduct electricity, but so do bases. If the base is strong, just like an acid, it can be corrosive as well. Okay. So just don't think that just acids that are strong are bad for you. So can bases. Now, this is not on your notes. Feel free to record anything that you think might be important here, okay? And at the bottom of the chart. And this is just to review. We touched on this after the lab. You heard about it in the video a little bit, and you also read about it for your Cornell notes. But neutralization is the process in which an acid and a basis come in contact. Sometimes we do it on purpose, like when we take an antacid, we are basically taking a weak base and we're adding it to our stomach contents, which is maybe too strong of a base at that time, and we're trying to bring it closer to neutral, to a 7, okay, which would help alleviate some of indigestion problems or a sick stomach, okay. So if you have equal amounts of acid and base and you mix them together, then you're going to have a neutral. If the strength is the same and you're putting the same amount, but it usually doesn't work out like that. So just because it's called neutralization doesn't mean that when you add a base to an acid, it's going to end up as a 7 on the pH scale. All right, so here are some interactive videos if you would like to use them. One is a brain pop. Don't know that you can get to that if you don't have a brain pop account, but the other one I think you can get to, so you can try it if you want. And that is it. So good luck with your studying.